Up to now, we've been doing a lot of mental math and some basic habits. I think now is about the point where I want to mention this, that I recommend getting a piece of paper, or even better, a notebook, a pen, pencil, whatever you want to write with, and doing a lot of these problems together as I'm doing them. The other thing is, I'm not going to be telling you guys to pause all the time, but as soon as you see a question, before I give away the answer, feel free to pause the videos and try to work them out before I give away the solutions. Why is this so important? 90% of learning math is doing and not just listening. You may think you have it just by seeing me do it once, but you'd be surprised how different intellectual knowledge is from experiential knowledge, right? Many of you know how to ride a bicycle and haven't ridden a bicycle in 10 years, and you go on and after 10 years and now you could still ride a bicycle. That's because it's in your bones. It's a very motor skill. So if you're not physically doing something, you're not going to learn it as well. All right, so that's what I want to say about this, and this will apply to all the future videos. While you may not need it for all the videos, I highly recommend just having it nearby. All right, let's warm up with a problem from the previous video, which is on grouping. So take a look at this one, try to figure it out. Like I said, this would be a good moment to pause the video and try to work it out yourself, but I'm gonna go ahead and do it with you guys now. So again, we're not gonna do this left to right. The other point about this problem is the grouping doesn't just apply to addition as in the previous video. It's a general concept that applies to anything. So let's group the 5 with the 20, the 8 with the 125, and now these look kind of ugly. So let's think about those for a second. So that's 100. 8 times 125 is 1,000. Now we sort of scan it. Okay, the 7 and 49 look pretty nice. The 13 goes into 169. All right, so we have a 7 and 13 left. Let's think about this. So these multiplied together are 91, and 91 doubled is 182. So actually 182 over these two is exactly 2. So here there's a little bit of a new concept where I'm not simplifying 1 to 1, but I'm grouping and simplifying. So I've killed off these two with this one instead of doing it always 1 and 1, 1 and 1. All right, so now what do we have left? We have 100, 1,000, the 3, and the 2. So that's 6. And what's 100 times 1,000? That's 100,000 times 6, so the answer should be 600,000. So the point was, we didn't need a calculator, we didn't need to do a lot of calculations, just a few little scribbles, and we can solve this problem. Now it's pretty contrived, but I just wanted to drill grouping. All right, so let's go into today's lesson, which is organization. So we're gonna do 2 problems. They're not meant to be super hard, but they're meant to illustrate how important it is to stay organized. All right, the first question, this is a 5 by 7 rectangle made up of little squares. The question is, how many squares are in this diagram? Now, before you go and solve it, I'm asking about squares of any size, not just 1 by 1 squares, but 2 by 2 squares. So for example, that's a square, that's a square, right? So there's a lot of squares in this diagram. So how would you solve this question? It's not that hard of a question, but the point is, if you're not organized, this will be a nightmare. If you just say, oh, found one, you're gonna lose track. All right, so how would I recommend doing this? Let's start with 1 by 1s. All right, so there's 5 by 7 of them. So there's 35. This is not 1 times 1, so let's not say equals. These are 1 by 1 squares, so these are dimensions. All right, let's go to 2 by 2. So here's your 2 by 2 square. And now instead of counting them again, we're going to try to do the same idea of, let's not even say 35, let's say 5 times 7. So these are dimensions, and this is the number of them. All right, so for the 2 by 2 squares, how many times can we move this horizontally? So we have 1, and then since the border line is 1 more than on a 1 by 1 square, instead of moving it 7 times over, we can only move it 6. So it'll be 1, 2, 3, 4, 5, 6. So the second number will be 6. And because vertically, instead of a 1 by 1 square where this is your leading edge, now in the 2 by 2 it's 1 lower, so you can't have 5 of them, you can only have 4 of them. All right, and now we're going to use this idea for all the other ones. So I'm not even going to redo this exercise. We could just get at this point we might find a pattern. Say, oh, these are going down by 1 because each time the square is getting bigger, so we can't move it as much. So this would be 3 by 5, 2 by 4, 1 by 3, and let's say we go to this one. So if we're blindly just doing this, you'll say, wait, how did I get a 0? Well, that's because a 6 by 6 square goes beyond the borders of this diagram. So there are no 6 by 6. And then we could just add up 35, 24, 15, 8, and 3. I won't even add those up. That's not the point of this exercise. If you want, you can add it up and get an answer and check with your buddies. But the idea here was that you're approaching this problem in this organized way and not just looking with your finger in your head and trying to find squares. All right, so that's number 1. All right, number 2. So now I'll be referring to this as the ice cream problem, and in future videos, there'll be a video much later on. We'll approach this again in a more clever way, so just keep this problem in the back of your minds. So here's the problem. So you have I'm no artist, but you have 4 scoops, and sorry, you get 3 scoops and 4 flavors. Okay, so here's how the problem works. You have 4 flavors, so it could be vanilla, chocolate, strawberry, raspberry. And you get 3 scoops. Now, for the purposes of this problem, the order of the scoops doesn't matter. So if it's chocolate, chocolate, vanilla, or chocolate, vanilla, chocolate, we're going to count these as being the same thing. So the question asks, how many different ways can you get 3 scoops using 4 flavors? And you're allowed to, as you've seen in this example, you can reuse flavors, but we don't care about the order of the flavors. All right, so again, you can start thinking about it. We're gonna start doing this together. Let's call our flavors A, B, C, D. Now, we could pick all of flavor A, so it would be A. Now, keep in mind, when I'm doing this, focus on the organization. I'm going to do this very methodically. I'm not just going to jump around to C, to B, to D. So we'll do AAA, then we'll do AAB. Then we're going to go AAC, AAD. Now at this point, we've covered everything with at least 2 A's. So now we're going to go alphabetically to A, B, B. Now you might be wondering, why didn't we go to ABA? Because ABA is just a rearrangement or permutation of AAB. This is why we're doing this organized scheme, because it makes sure we don't overcount anything or double count. So then we go to ABC, ABD. Now we're done with AB. We go to AC, ACC, ACD. So hopefully you're seeing how we're counting this. Then we go to ADD. And now it looks like there's going to be a lot, but actually we're done with the A's at this point. So we're going to go to B, 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 C, All right, now we're done with the B's. So we're gonna go to C, 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 D, C, D, D, and we're done with the C's. Now we have D, D, D. Let's count them up. So there's 20, and that's not the point of the problem. By the way, later, like I said, in a video when we get to combinatorics and permutations and combinations, we will see how to do this problem very nicely in an even better method. But for now, if you're going to list them out, make sure you're listing them in an organized way. Notice we're going alphabetically in increasing order, so it's always from left to right. The letters are at least equal or going up, so it's AAB. It's not going from like BBA. And the purpose of that is that we're organized and we don't commit this mistake of counting this and then counting that. So we're not just doing this however we felt like doing it. Okay, I'll leave it at that. So keep in mind, as we're going to be doing all this math, organization is very important. Not organization for the sake of organization, but organization to help us be more efficient.